Okay, so in this video, we're going to take a look at logical connectives, right? And these are sort of symbols that are going to connect mathematical statements together. Now, it's a simple idea, but it's going to take a lot of practice to get used to this. So it's just going to be simple things to get you to understand what this all means, all right? So let's just quickly have a look at this box here. I would write these down, have them to reference, all right? And really the key thing is that when we see the arrow pointing up, it means and, right? So A and B, right? When we have the symbol pointing down, it means A or B. If we have a negation, such as the little symbol there, look, an A, it means things that are not A, the opposite of A, okay? Now then, if we see something like this, right? Then that is that A implies B. If A is true, then B is true, right? And if we see something like this, well, it means if A is true, if and only if B is true. It means both that A implies B and that B implies A at the same time. All right, now that's really confusing. There's lots going on there. Let's just go through these again a little bit slower and make sure we really do understand this. So let's think about this, okay? So maybe we've got a statement here. Remember, that arrow pointing up means A and B. Well, this reads that A and B imply that C is true, right? And of course, if A is true, then the opposite, the negation of A, is going to be false and vice versa, right? Okay, this is all perfectly logical if you go back and look at those original statements, all right? Okay, so then, now some of the words we use, right? If we have something that reads like this, okay, A is implying B, well, A is our original hypothesis, what we're starting with, and we draw a conclusion that therefore B is true, right? So look out for the words hypothesis and conclusion when you're dealing with this. All right. If a converse of an implication, so we've just got this symbol here again. Look, A implies B is the opposite way round. B implies A, but they don't have to be true. And this is a fantastic example, right? Have a quick read of this box. Pause the video and just consider this for a moment. If X is equal to 2, then X squared is 4. So maybe we can imagine that this statement here, look, is A, and this one here is B, right? So does A imply B? Yes, it does. If X is 2, then X squared is 4. However, does this work out? If X squared is 4, that's B, then X equals 2? Well, no, that's not true, is it? Because they don't have to always be the same, because we could have that X was originally minus 2. So be careful. Just because one implies the other, it doesn't mean that it works both ways round. Okay, now it can work both ways round, and if it does, then we have this if and only if statement, this equivalence, right? So we can use the double arrow. So a good example of this is given if imagine that A is that X is equal to minus 2 or 2, and B is X squared equal to 4. Well, this statement does hold. It works both ways round. If X squared equals 4, then X is either equal to minus 2 or 2. And if we have X equal to minus 2 or 2, then X squared is 4. It works both ways round. So this is one where it does work, and we would say A and B are equivalent, and we can write that symbol. Okay, so let's look at some more formal examples now. Nice, simple stuff. Keep looking back at that box. Look, okay, screenshot that if you want to. Okay, keep an eye on that, and let's try and read these and decode what each question means. No difficulties, though. No horrible questions, just common sense. So in this question, we're asked to find the negation of these propositions. A proposition is just really a statement, okay? It says X and Y belong to the real numbers, so they just appear on the number line. So if X is less than 5, well, the negation is the opposite, right? Okay, we're looking to say, well, X greater than 5, all right? It's or equal to 5, excuse me. And B, if X is greater than or equal to 3, well, the negation of that is X is less than 3. If y is less than 8, well, the negation is going to be y is greater than or equal to 8. It's the opposite, right? And then in D, y is less than or equal to 10. Well, the negation is going to be y is greater than 10. And let's keep referencing that there. Look, it means not, right? Okay, it's the opposite. And if I was writing the symbol, it would be that one there. Okay, let's move on. So what does this mean? Okay, well, write that out, okay? P and then an arrow pointing up Q for the following pair of propositions. Do you remember what it means? It just means and, right? Okay, so all I'm looking for A is just to say Ted is a doctor and Shelley is a dentist. That's it. What about B? If x is greater than 15 and x is less than 30. So I could write that out in a statement, x is greater than 15 but less than 30. But maybe I could use some mathematical language here, right? Could we write this as an inequality? X is between 15 and 30. There we go. C, well, P and Q is just going to simply be it's windy and raining. Okay, all I need you to understand is what this means. It means and, right? And D, well, Kim has brown hair, Kim has blue eyes, so Kim has brown hair and blue eyes. Okay, easy stuff this, right? Let's move on. Okay, so what about this one? This time we've got the arrow pointing down. For those propositions, can we determine if it's true or false? Okay, so now this symbol means or, right? So if we have an or statement, well, only one of them has to be true, right? So let's think about this. So if we think about A, right, we've got 24 is a multiple of 4. Well, that is true, right? I'm going to write true. And Q, 24 is a multiple of 6. Well, that's true. So think about P or Q. Is one of those true? Yes. In fact, they both are in this case, all right? So we're going to say true for this particular case. What about B? Okay, so P, there are 100 degrees in a right angle. Well, clearly, that's going to be false, right? Of course, that's not true. Q, well, there are 180 degrees on a straight line. That is true. So therefore, what is P or Q? Is it true or false? False. Well, in order for the or symbol to kind of work, right, only one of them has to be true. They don't have to both be true, right? Either P or Q is true. So that means that this actually is a true statement. If I had used that symbol pointing up, are they both going to have to be true? Well, then we'd be wrong, wouldn't we? We'd be false. All right. But in this particular case, maybe we could write that just as an aside, right? If I was thinking about this one would be false. Okay. Right. What about C? So -8 is greater than -5. Well, that is definitely false. What about Q? 5 is less than 0. Well, clearly that's false. So what is P or Q going to be? Well, neither one is true. So that means that this whole thing is going to have to be false. And there's our answer for part C. What about D? Well, the mean of 5 and 9 is 7. Well, if I add 5 and 9, I get 14. Divide by 2. Yep. Okay. P. That's true. I don't even need to do the next one, do I? Even if it's wrong. The mean of 8 and 14 is 10. Well, that's false. So I've got one that is true. So therefore, this is a true statement. Okay, hopefully that made sense. Let's move on. Determine whether A or B are equivalent. So in order to get equivalent, we need to think about, does A imply B? And if it does, well, the other condition is, does B apply A? And if both of those things are true, then we can say that they are equivalent, which is that symbol at the bottom there. So does A imply B? Let's read this. So XYZ is equal to 0. Does that imply that well, we've got arrow pointing down, so that means or. That means either X is 0 or Y is 0 or Z is 0. Well, that's true, isn't it? Yeah, A does imply B. If XYZ is equal to 0, then B kind of must be true, right? What about the other way around? Does B imply A? If X is 0 or Y is 0 or Z is 0, does that imply that X, Y, Z is 0? Again, yes, it does. That's true. So we have it both way rounds. So are they equivalent? Yes, they are. A implies B and B implies A. There is equivalence between A and B. Right, let's do one last question. I love this question. Okay, read it very carefully. Pause the video if you need to have a think before I show you the answer. So there are 4 cards on the table, and there they are, look. Okay, every card has a letter on one side and a number on the other side. With the cards placed, you see D3, K7. Now, identify precisely which card you need to turn over and which you do not to establish the truth of this statement. And let's read this really carefully. Every card which has a D on one side has a 7 on the other. So pause the video and consider that. Now, we're going to go through the cards one at a time. Let's start with the D. So do we need to turn that over to establish the statement every card which has a D on one side has a 7 on the other? The answer is yes, because of course we need to turn it over. If it's got a 5 on the other side, well, clearly we can say something about that statement, okay? So that to me makes perfect sense, of course. Okay, so let's write a little note, okay? We're going to turn over. We're looking for a 7. Is there a 7? Right, what about the 3? Do we need to turn that one over? Yes, we do, right? Because okay, we're going to have to turn over, because what if there's a D there? Is there a D? If there is, we will know our statement is wrong, and if there isn't, well, it doesn't really matter, okay? That doesn't really establish anything, but we need to see if there's a D or not, right? Okay, what about the K? Do we need to turn that one over? Well, no. We know that there's going to be a number over there, right? Even if it's a 7, it doesn't really make any sense to us. I don't really care, because I'm only considering this one way round. The important bit is, does a D imply a 7, right? If there's a 7 on the other side, it doesn't really invalidate my statement. So no, we do not need to write this down. Now, what about the last one? What about the 7? Do we need to turn it over? No, we don't. We don't at all, right? Because even if it has a D, well, no problems. Okay, I get that, right? But it doesn't matter even if it doesn't. It's not going to invalidate my statement, because supposing it's an E, well, again, that means that it's not part of the statement I started with, because it's only one way round. D implies 7, not that the 7 implies a D. So I don't really care if it's a D or not, right? So the answer to that one is no. Okay, hopefully this has just given you a little taster of some of these connectives, how we can start thinking about them and then use them in the later videos to do some work on some